Okay, where is everybody? Look at that, we have a 1-to-1 teaching ratio. See, who says you can't get personalized attention in a big state school? Oh, you've wrecked our ratio. All right. So today we are going to talk about Elastic Map Reduce, aka Hadoop. Okay, so Amazon has the ability to run Hadoop jobs in the cloud. So they give it the name EMR, Elastic Map Reduce. So a couple of things on about this, right? So I have this little link here on our page, Beginner's Guide to Hadoop, and so you can kind of go through and take a look at some of the things. They talk about the name nodes and various things. The thing that I actually wanted to kind of talk about is actually right here. Okay, so the MapReduce pipeline, right? So here's the basic idea, right? So the basic idea of Hadoop is actually a fairly simple one, and it comes from functional programming. Okay, so in functional programming, one of the key tenets of functional programming is that functions are first-class objects. Okay, and basically what that means is that anywhere you can provide, say, a variable, you can use a function. So for instance, I can assign a function to a variable in a functional language. I can write functions that take functions as parameters. I can even write functions that return functions. So that's really the idea, right? And two of the basic kind of higher order functions that we tend to see are map and reduce, okay? So the idea behind map is that basically it takes some input, oftentimes something in the form of a list, and basically creates a brand new list by applying some operation to all of the elements in the list. Okay, that's the typical classical functional definition of map. Reduce is roughly the equivalent to think of things like summing up a list, computing the product of a list of numbers, a few things like that, right? So basically taking some collection and kind of condensing it down to some form of summary statistics, etc. Now what's really cool about map and reduce is that it is incredibly easy to parallelize them. Okay, so if I'm dealing with a lot of data, if I'm dealing with, for instance, a mapping task, there's nothing preventing me from saying, oh, okay, you know what, instead of basically doing this entire thing sequentially, what I could do is split up the input and then have several mappers all run the same code together and then just combine that stuff after I've done the result. And it turns out that because of the semantics of map, doing such a thing, basically you get that parallelism almost for free. One of the functional languages that I use quite frequently, Clojure. Basically the difference between map and parallel map is one letter. You call p map, which basically does the exact same thing as map, except it automatically parallelizes it. Okay, it is actually a very simple idea, right? So the notion is, so you can see in this diagram, they have what they call the HDFS, stands for the Hadoop file system, right? Basically, it feeds our data into a bunch of mappers, right? The idea is, again, this is set. So the reason for using MapReduce is when you're dealing with very, very, very large data sets. Okay, and so certainly these days, with the gig economy, we tend to have lots of data to be able to analyze, right? Think about things like web server logs, right? If you have a popular site, you're probably having thousands upon thousands of hits to your website, perhaps a minute or perhaps a second, and so that's going to generate a ton of data. Think about things like how cookies are used to track individuals and their preferences, right? Again, we're gathering all kinds of information about individuals to find out their preferences so that we can hopefully sell them other things, right? So dealing with huge amounts of data, basically, that's where MapReduce comes in. The idea is that you can have multiple machines, as many as your little heart desires, well, and your wallet will afford. And basically, you have all these machines, and again, the Hadoop framework will essentially automate the parallelizing of the task for you. Okay, so it's really, really cool. If you've done any kind of, manually parallel code, it's just a nightmare. So this actually is way, way simpler, right? So the idea is that, we can have various mappers running potentially on a number of different machines. They basically output this stuff. We can have some partitioning, right? Then we do sorting before we send that along to the reducers. And finally, the reducers basically do their job to generate the ultimate answer and again, spit that out as a separate file, okay? So that's roughly the idea. We'll take a look at what that means in practice. It turns out in terms of code and all, there's not actually a ton of code that we're going to have to write for these things. Okay. So I have a project of the beginnings of a project set up here in PyCharm. The framework that we're going to use, or the library that we're going to use, is called MrJob. MrJob basically is a Python module that allows you to do Hadoop jobs. And what's nice about it is that it also plays very nicely with not only Elastic Map Reduce but other cloud providers as well. So you have a lot of options in terms of running your code. The other really nice thing about it is it actually makes testing your code locally dead simple. Okay, so again, kind of a nice thing because then we don't have to constantly have our cluster running within Amazon to be able to run this stuff. Hadoop itself is actually written in Java. Okay, and generally the main interface for it is that you write Java code. The way that we're able to write Python code, it used to be that if you wanted to write Python code, basically what you had to do is you wrote it in Jython. How many people have heard of Jython? Right, so Jython is a version of Python that actually runs on the Java virtual machine. Okay, so basically the Python code gets compiled down to Java bytecode, and then so you can see how then that would play in with the Java ecosystem of Hadoop. Hadoop has evolved over the years. We now have what's called the streaming API. And the streaming API basically means you don't have to use Java anymore. You can write your MapReduce programs in whatever language your little heart desires. And basically then in the configuration say, here's my mapper, here's my reducer, and then off it will go in terms of running your code. So really, really kind of nice. And that the setup is a little intricate and so forth. Again, using something like MrJob will allow you to get up and running very, very quickly. Now, there is a downside to MrJob. So if you do some Googling about the various Python frameworks and so forth, it turns out because of the way that it goes about sharing information and basically is serializing data to, as my understanding is, JSON, what ends up happening is that actually provides additional overhead. So if we compare, for instance, running MrJob, a program written for MrJob versus just for the streaming API, it turns out the MrJob is a little slower in terms of its execution because of what's happening behind the scenes. But the advantage, as I said, is essentially that you kind of get up and running quicker. There's a lot of good documentation and so forth. Okay, so that's what we're going to look at here. All right, so the first thing I'm going to do, let me set up a virtual environment, so Control-Alt-S, and let me go to my project and my project interpreter, okay, and I'll just create a VirtualEnv here. And let's put it in the right place. So, oh no, actually I have it on, where do I have it? I have it on the desktop. Bless you. Okay, so there's the folder for that. I'm not going to bother installing the. Well, yeah, why not? Doesn't really matter. Okay, so we need to install MrJob. So it's just MrJob and install the package. Okay, so while that's doing that, let me go ahead and create a new Python. So I'll do the obligatory. So of course in the world of programming, we oftentimes for a new programming language we will write "Hello World." Seems to be obligatory. The obligatory "Hello World" for Hadoop and Elastic Map Reduce is word counting. Okay, so that's kind of what we'll look at. Call this Mr. Word Count. Okay, so let's see. It did say installed. Good. So I should be able to say from MrJob import MrJob. Okay, that's one of the things that we will be using. Now, MrJob is an object-oriented framework. Okay, so to create a job, you basically need to create a class that inherits from a particular class in MrJob, namely the MrJob class. So I'll just say class, and I'll call it MR. Now, come back to that in a minute. Then let me go ahead and add in the typical boilerplate for doing a sort of main method in Python. It looks something like this, and then we'll say mr wordFrec count and call run. So there are two main methods that we basically can override to do whatever task we need done. So the first is the mapper method, and in terms of the parameters, I'm going to label them thusly. So you'll notice actually this middle parameter, I've basically given the name underscore because essentially we're not using it in this particular case. Then we'll also have our reducer, and it will take parameters like so. I forget. I'd have to actually look that up. In the mappers, in general, you'll see that that particular it probably has to do with a key value, but the mappers tend not to use that particular key. Now, here's where it gets a little hairy. Okay, so to basically use this, we need to turn these functions into what are known as generators. Okay, so a generator in Python is a sort of special function, right? So the notion is, how many people have heard of iterators? A couple. Iterators are a design pattern. The idea is, in Python, for instance, take our for loops. When we say for such and such in some particular thing, that thing could be a list, it could be a dictionary, it could be a string, etc. Why can it be all of those things? Because all of them are iterable, right? They're iterable because they return an iterator. An iterator simply has a next method that basically gives me one of the values and sort of advances the iterator through the collection. Okay. A generator is a similar type of mechanism. And to generate items, is actually fairly simple. So let me actually I'll just write some code here just to kind of show you. Right. So I could do something like this. I could have yield and 5. Right, so there it is. It's a generator. That generator basically yields a single item, 5. Okay. Then when I go to use this, right, we can see, let's see, from right. So notice when I call it, it comes back and says, "Oh yeah, that's a generator." Right. I could make a list of all of the items, which is just the 1, 5. I could also use that, right, so for n in mygen, print n, like so. Now you might say, well, okay, that's great. Why not just do return? Well, because what yield allows me to do is actually specify as many things as I want. So for instance, I could have yield this, and yield 7, and yield 3, etc. And there they are. Okay.
Can we recursively call mygen?
Sorry?
Can we recursively call mygen?
Can you recursively call it? That might be weird. I've not seen a recursive generator, but there's nothing preventing me. You know, I mean, I could do something like, I could actually have something like this. Nums is equal to I don't know, range of 10, and then I could have and then I could basically just have for n in nums yield n. Okay. So yeah, you can do stuff like that as well. And you can even actually make infinite generators, so to speak. Okay. Now, there's a whole sort of theory behind it. They talk about the formal name for this are coroutines and so on and so forth. The good news is, as long as you can understand, look, when I need to return a value from MrJob, I basically need to yield it. That's really all you need to know. Okay, so if the idea of generators hurts your head, it's okay. You can still use MrJob. Again, as I said, basically, just remember you're going to yield individual items. So here's what we're going to do, right? So we're going to actually yield a few different things. So I'm going to yield, for instance, the number of characters, right? So whatever this line of text is that I get, basically I'll say, okay, here are the number of characters, right? The way mappers need to work is basically they need to yield two things: a key value and some particular data. So here our key value is chars, together with basically how many characters there are in that particular line, right? What happens then is eventually, because of our sorting going on, right, what will happen is our reducer basically will get called with similar objects. So essentially what will happen is we'll have things like the keys all matched up for all the values for a particular key will be matched up, okay? And we'll see what that looks like in a minute. We'll compute some additional stats as well. So we'll kind of take this beyond just the simple counting up of characters, right? So for words, I'll just do a real simple line split, like so. So line split, when it's called without a parameter, will basically just split on any white space. Okay, and then we can also say, okay, how about the lines themselves, right? Well, we basically have one line. We've read one line, right? So we just we basically output that. Okay, so that's what our mapper looks like. Our reducer, even before, well, let me do. right? So ultimately, what I want is the particular key, whether it's characters, words, or lines, followed by a sum of the values. Okay. And that's it.
You're adding characters?
Pardon?
You would be getting a characters, right?
I will actually get a count of all of the characters, a count of all of the words, and a count of all of the lines from just this. Okay, so let's take a look. So let me go ahead and run this. First thing I'm going to do, so I'll go ahead and try to run this outright. It should probably die a horrible death. Yeah, notice it's saying reading from standard in, right, because I didn't specify the input file and so forth. Okay, but basically that gave me my runtime configuration up here that now I can manipulate. So I'm going to come up here. So I have a couple of things here, right? So one, in this folder, and I'll post all the code and everything, I have this file here, MrJob.conf. So this conf file allows me to set various options for for when I run my jobs. So you'll see I have a couple of things here. One, I have this runners section. So one set of runners is called EMR. Basically, these are the options that we're setting for when we decide to run it on Elastic Map Reduce. Down here is the option that we have set just for when we run this locally. Okay, so basically I'm saying, okay, for my temp directory, I'm going to use the temp directory that happens to exist inside this project, right? I actually created a little directory in here called temp that just has, oh, actually, sorry, it's the wrong one. Yep, there's my temp directory. Since I haven't run it yet, there's that. So we can specify the temp directory. You see here, I'm actually also specifying the time zone when I kick it up to Amazon. There's some other options here that we'll kind of talk about later. To be able to use that, basically what we need to do is here on the command line for the script parameters, I'll say conf dash path equals and then MrJob.conf. And then basically I can specify the file that I want to run this on, right? So the source file itself is a text document. So I can compute the statistics just for this. Let's take a look, right? So I do that. Let me go ahead and run this. This error is not uncommon. You'll see this, notice access denied. It's basically complaining because after it sort of generates the stats, it goes to delete it. It seems that periodically it goes to delete it while it's still using that. Here are my stats for that particular file. Right, so characters is that, lines is that, words is that. Now, again, let me show you a bit more. Let's kind of peel back the veil, so to speak. So if I print key, comma, values right here, just so we can see what we're actually getting as input to this. So there's that. Right, notice, we're getting back, the value part is a generator, right? Namely, stuff that's returned here. Now, again, to sort of peek into that a bit more. Now, one thing, putting in this kind of debugging information is great for learning about how MrJob and MapReduce is doing its thing. However, this is going to break my code. You'll see in a minute, right? So there's my stats again, right? But if I go to run this, right? Notice my stats are all zeroed out. Why? Because I consumed the generator on the print line. That's why. Okay, but notice we can see. So what do we get back? We get back characters and this, right? For each of the individual lines, those are the character counts, right? Then for each line, we generate things like that. For words on each line, we get this. So thus, when we do our sum of those particular values is how we basically then aggregate that together to get our result.
So, like, what is the input?
What is the input? The input is this file itself, right? So literally what I did is I sent it, I gave it this particular this file, right? So this file here is basically what it's producing the stats for. So let's see, it's we do have 24 lines. What did this? Oh wait, let me take out my my print statement first, right there. "24 lines, right? And there's the number of words and the number of characters. Okay.
So we have basically one reducer and a lot of matters in this example because you told.
Sorry, say that again.
We have here one reducer, like one thread that reduced, and many mappers, yes, in this local environment.
Right now, most likely, I probably have. I'm not sure actually how many it actually uses offhand. It may actually just use a single mapper and a single reducer, but it can actually parallelize it a bit, and that's certainly fine. Okay. Obviously, when we push this up to the cloud, then things can basically get bigger and so forth. Okay. All right. Now, before we kind of do push this up to the cloud, let me do a couple of things, right? So, first thing I'm going to do.
What is the result that is storing it in the temp folder?
Sorry?
What is the result that is?
Yeah, you can take a look. So here's the temp folder, right? You can see basically it gives us information about steps. Here's the mapper output. So you can see actually, it looks like it actually used 14 mappers on this. Okay, so a few. In terms of reducer, let's see, what did we have? Yeah, we actually had 4 reducers running. Okay. And again, you can kind of go through and see the input, the standard error, right? Those kinds of things and so forth. Right, so that's...
So in the cloud it will be the same. Like
in the cloud, basically, ultimately, it's the same for its temp directory. Yep. Okay. Now, spinning up a cluster, a Hadoop cluster, takes a significant amount of time. Right. By that I mean so generally I'm seeing times taking about 10 minutes to actually just start up the cluster itself. Okay. So given that, right, generally you probably don't want to kind of keep testing this through and spin up a cluster, wait the 10 minutes, then it runs your job, then basically you get back the job, then you take the whole thing down, etc. Right? In that case, it's kind of silly, right? Certainly testing. So one thing we can do is I can actually start up the cluster, and then I can submit multiple jobs to the same cluster. Okay, so notice the MrJob command, which gets installed basically once you've installed the package. Here are your various options and so forth. Right, we're looking at create cluster. Right, so let's see. I'm going to go to my notes here. So MrJob and then create cluster and conf path equals MrJob.conf. Now, a couple of other things that I'm just going to point out in the configuration file. Okay. So you'll see there are a few things that are commented out. So one, you can actually specify the region that you want your Hadoop cluster spun up in. The default region actually is Oregon. Okay, I tried this with US East 1, which is North Virginia, as well as US East 2, which is Ohio. In both cases, I repeatedly got issues. In the North Virginia portion, The problem basically comes down to if it runs in the wrong availability zone within there, then it dies a horrible death. In East 2, what the problem that you get is the default instance size that MrJob will use is this here, M1 medium, and those don't exist in the Ohio region. So again, you end up having issues there. So at that point, I basically just commented out the region altogether and said, yeah, I'll just let it use Oregon. The key pair stuff. Okay, so when your cluster gets created, you can, like other things, you can basically specify a key pair to use. Here I created a separate key pair. I've called it EMR. Right, notice it's the actual PEM file that you download originally. It's not a PPK file. What these two lines do, there are actually two things that it does. The first one basically selects the EMR key pair for the instances when they're spun up. The second one allows MrJob to basically be able to use the key pair to try to connect to the instances for monitoring and so forth. Okay, you don't have to have them there, but certainly you can. Notice you can actually control the number of instances that you have. Right, so we have sort of our name node, the master thing that controls everything. Then we have our core instances that basically are doing the work. So here I have it set for 2. This one here. Right, notice the comment, very important, especially if you're going to do what I just did, which is namely that I am doing. There, now it's running. Or should. There it goes. Right. So here I've basically started up a cluster. Right. These clusters are fairly large. Notice are using much larger instances. So these certainly don't even fall into the free tier. In fact, M1 medium is the smallest instance that you can use. If you go to create a cluster from the console itself, you'll see it will the suggested one that it will use is an M3 extra large. So it's even bigger than this one here. This max mins idle basically lets us define the number of minutes that the cluster can be sitting idle before it shuts itself down. Okay, so here I've set it to 30. That way, if I don't use it within 30 minutes, it basically just terminates itself, and I don't have to worry about it. Right, and once again, then we set the temp directory. When you set up, in fact, you'll actually see right here, when I started this up, it said, copying files to an S3 bucket. It basically created a random S3 bucket. If you wanted to manage that stuff yourself, you can. I have 2 lines in here that are commented out, but you could uncomment them, right? So you can specify where you want your logs to go. You can also specify the temp directory that you're going to use on S3 as well, right? So there's that stuff there. Okay, so that's started spinning up. Let's see. Yeah, starting. It's probably going to take another 7 minutes or so. So I'll continue talking while that's doing its thing.
What is the price?
Pardon?
What is the price for?
The price you're paying for the time for the instance is running. Right. That's basically how it's built.
So would that include 30 minutes? So like if my instance run for the 5 minutes and it is getting ready for the 30 minutes. So
Remember, so if you left it running for the 30 minutes, then basically you're sort of paying for that. And then of course you do have some of the charges for data in out kind of things as well.
So Amazon will automatically decide which core node will be reduced and which mapper, yes?
Yeah, right. It basically will auto partition your system for you, and it's a feature of Hadoop, not just Amazon's Map Reduce. Right, so basically it sort of auto configures itself saying, okay, well, we have this many nodes, all right, I'm going to kind of figure out, and I'm sure there's probably ways of then configuring additional jobs and so forth. As I said, I mean, you can see you can certainly bump up the instances if you are dealing with a larger job and so forth and all of that. All right, let's look at another. Okay, let's look at another example or two. So, Yeah.
So basically, we have Hadoop file system or like file system that distributed around those two cores, yes, and file will actually spread around two cores.
Right. So essentially so you'll notice so for the file, ultimately the file initially gets put into an S3 bucket, right? And so essentially Elastic Map Reduce kind of has this wrapper around that for being able to grab files from S3 buckets, write them back out to S3 buckets. So yeah. All right. Let's see.
So can we create a configuration in which we put in the bucket files to process and Hadoop will automatically process it?
Right. So you can upload your input files to S3, and then when you run it, just have it use those files right off of S3. If you don't, what will happen is when you go to run it, it'll basically upload those files to S3 on your behalf, anyways, and then kind of go on from there. So we'll see that kind of when we do this stuff. Let's look at another little example here. This one actually, if I remember right, is from the MrJob tutorial. So let's call this most used word. So the job that we've seen, this job that we've seen, basically has a single step, if you will. Essentially, we have a mapper, we have a reducer, and that's all that we're doing. In larger projects, you actually may have multiple steps that you're going to go through. Okay? So that is, I may have multiple mappers, multiple reducers, etc., to be able to generate the data that I'm interested in. Right. So that's actually what we're going to see here. So I'll do create class most. Okay, so first let me create the mapper. So I'll call this one mapper get words. Oh, yes. Let's see, \W. Oh, yeah. So there's a regular expression for separating the individual words, right? So then we're just going to have for every word in word RE find all on line, and so we'll say yield that. Okay. Technically, I don't actually need the parentheses, and I think actually the style thing will complain about that. Right? So notice, we output the word in lowercase and basically account for it. We've seen it once. Right? And so if we do that for each of the words, again, because of the whole sorting and grouping that basically happens, eventually those ones get grouped together like we saw in the previous example. They also add, so in addition to mapping and reducing, there is a combining step as well. And so combining basically happens to kind of generate the stuff to ultimately feed to the reducers. But what it ends up leading to is code that actually very frequently looks quite similar, right? So let me just put in the comment that they have here. It's an optimization. You can think of the combiner as a process that's going to work on an individual node to take basically the results of the mapper, combine those together before shipping them off to the reducer. Basically, it reduces essentially the amount of traffic that we have to send between the various nodes. Okay, so that's really all that's happening there. Okay, so we'll have reducer, count, words. Again, it has self, it has words, it has the counts. Okay, and then we're going to do this. So, providing basically none for the key.
Is it compulsory to use like mapper in the function if it's a mapper function?
Actually, with what we're going to do here, you don't have to, you could name it whatever you wanted. You could name it foo. With what we did here, where we just have a mapper and a reducer there, you actually want to use those names. You can see here, these are actually overrides of existing methods, right? With the way that we're going to set it up here, we'll see the setup in a minute, basically I can name it whatever I want. Okay, so we'll say num, and then we'll just say a sum of counts and the word. And this one I do want to put parentheses around. Okay. So that's our first step. Then we'll have another one, namely we're going to call it reducer find max word. And so here we could simply do, let's see, yield. Now, counts plural. There we are. Okay. Now that we have a whole bunch of things here. Question? No, that's the point. I actually, in this case, we're throwing away the key altogether because we don't really notice. We didn't even specify a key. We specified none for the key. So all of the things are going to filter into this this individual reducer. Okay. All right. So now we define our steps, and the way that we do that is just create a steps method that is an override. And this just returns a list of step objects, namely MR step objects. So I create an MR step object for the first one. So its mapper is going to be self dot mapper get words. Its combiner.
Is it compulsory to write those overload the step method at the start of the class, or we can write that?
You can put the steps method wherever you want. Yeah. So this one is self combine count words, and then its reducer is that. And I want to actually take out the parentheses there, because I'm literally passing along the functions themselves. Then, so that's the first step. Then we have a second step. Right? The second step only has a reducer. You don't have to use all of the things. You can use exactly which ones you want. Right? So the reducer that we're going to use is that final one, which is and self. So there's the steps. Okay, so we've defined our functions. We've defined the basically the flow, the workflow, if you will, of exactly what needs to be done. Okay, so again, let me go ahead and run this. It'll say it's trying to. Oh yeah, doesn't say anything because I forgot to put my boilerplate code here.
this Python code has one mapper, one combiner, and two reducer.
Yes. Yeah.
One potential configuration for
The conf file?
not compile, but
Oh, the steps.
script parameters for running locally in the run
Oh yeah, that's what I'm going to do now, right? So if I go to edit configurations, right, so now I have my most used, right? So again, to specify the conf file, it's conf path equals then the name of your conf file. And then basically the name of your input file. Now I happen to have, where do I have? Oh yeah, here, right? So I happen to, well, I'll show it in a minute. Let's see. Okay. So Gutenberg.txt is basically contains the full text of. How many people have heard of Project Gutenberg? Project Gutenberg is an online. It's an initiative to provide open source full text access to books. So you can go to Project Gutenberg. You can download all manner of books on different topics. A lot of famous books are there and so forth. So what I did is I actually grabbed like 3 different books, threw them all in this one text file. So you can see, you know, if I were, so there's the text at Ulysses. Let's see. Forget how big this is. There we go. It's 78,233 lines. Okay. So a little bit of data. All right, so I'm going to run it on that. Oh, no? Oh, yes, that's right. Find max word. There we are. None type is not iterable. Really? What happened here? Let's see. I'm getting that. Oh, that's... I forget words. Just in case, although it shouldn't be. Let's see. So that one's working, the other one isn't. It's curious. Why is that the case? It's taken a minute or so. There we go. Now we're in step 2. Right, so let's see. And, oh yeah, right, because I have changes in this one, sorry. And it turns out the is the most commonly used word in that, right? It occurs 47,364 times. Okay, now, okay, that's not terribly helpful because, well, yeah, it's the. And maybe what I actually want to know is what are the rankings of all of the words, right? So to do that, we change our code like so. Okay. So we get our word count pairs. For every word count in, basically, we sort it and we pass along reverse equals true, so that makes sure that it sorts them based on their popularity from most popular or most frequently occurring to least frequently occurring, and then we just have a yield for that word count pair. So doing that. Right, and there they. And there they are. Yeah.
What if I want to know where the is used or any letter is used? The line
Sorry?
number and the column number. Like where the is used.
That would, well, I mean, if you want to know, if you want to basically create an index of where, I mean, it's totally different code. Right, but yeah, I mean, you could certainly create, I mean, it's up to you what statistics you're looking to pull out of your data and so forth, right? I mean, that's totally up to you. All right, yeah.
Where was the error with non-type?
Sorry?
You had an error, non-type is
That, yeah, that one I did, right, and I don't know, right, when I was, that was in this version of the code, or wait, no. Yeah, that was in this version of the code. I'm not sure why, so I'm gonna have to go back and look at compare the two side by side to figure out why the one is generating that and the other one isn't. 'Cause as far as I can tell right now, they're the same. All right, let's look at a couple of other quick examples. So, have here and there. This time,
You created an EMR on the Amazon cloud.
I have created it. I haven't used it yet.
Okay.
What's an anagram?
Like you can read the same place on the other side.
That's palindrome. Right? So anagrams are words or phrases that basically contain the exact same letters, but essentially in different orders, right? So here I have two files basically for dealing with anagrams. So I have a fairly large dictionary file, this words alpha text. So you can see going down. There are 370,000 words. Okay. So again, a little bit of data. And basically, here's the task: figure out which words are anagrams of other words that happen to be in this list, and then basically try to find the ones that have the most anagrams. Right. So again.
So what's an anagram? I did not understand.
Pardon?
What's an anagram? I did not understand that.
An anagram is a word or two words or two phrases. They have the exact same letters, but of course in different order. Okay. So stop and pots are anagrams of one another. Right. So here's the code for this. And again, it's really not a ton of code. Notice, I don't need multiple steps or anything like that. So we have our mapper, right? Basically, we get our individual word. The idea is what the mapper emits is, as a key, it takes all of the letters in the word and sorts them. Okay, so that's your key value. Think about it. Stop and pots will basically have the same sorting of letters for themselves, right? So we do that, and then the value is the word itself. Okay, we let then the reducer basically group these things together. So notice we get so we're going to yield the sorted letters together with the list itself. Okay, so if I go ahead and try to run this, let's. So if I can get that, edit our configuration here. Conf path, MrJob conf, and words underscore alpha dot text. All right. And so here are, actually it looks like we sort of lost some of our stuff. I could output this to a separate file, but you can start to see, okay, so here's the sorted letters, here are the words that basically match all of that, right? But again, ultimately I'd probably want to perhaps try to sort this maybe from most number of anagrams to least number. And that's where this one comes in. So the sorted version, not unlike the most used word, right? So again, notice we basically have our steps. So I'm not using a combiner here. I just have a mapper, a reducer for our first step. The mapper basically does the exact same thing as we saw. The reducer, the only difference is essentially, again, we're returning the none as the key, but then the value that we're returning is both the length of the anagram list and the anagram list itself. Okay, and then our reducer basically does what we saw previously for sorting all of the results. And words. Let's see this. Check the status of our cluster. It died. Probably timed out. All right.
So after this, can you also show like how they specify the name of the output file?
Yes. Yeah, I'll show. Yeah, so I'll show that. Let's see. Go back to run. So yes, we did lose some. So the easiest way, actually, I mean, we can just run this. You can just run this from the command line. So on all these, I tend to put actually I have a little comment in the file for what you would want to do for running it from the command line, right? So call Python on your program. There we pass along the conf file, right? There's our input file, and then we're just using the redirection operator, right? So output that to sorted anagrams dot text. All right, good, and let's see, there's sorted anagrams.text. And so there it is, right? So the most number of anagrams is 15, right? So alerts, alters, etc., right? And then we can kind of see how they go down from there. How many are there? There you go.
So basically, is there a way to filter out the ones, because single words cannot be considered an anagrams because it's just one word.
Sure.
So while using a reducer, can we filter out those words only when the list?
Yeah, actually, I mean, I could. So, I mean, I could certainly do. So I could add in something. I could add in. Here it is, right? Of if. Let's see, AP sub 0 is greater than 1. Right. So as long as it's greater than 1, then we actually output it. Otherwise, we don't care. Sure. Yep. Okay, let me show you, what is this doing now? Let's see. Yeah, that's starting. It's probably going to take just as long. Okay, so let me do it this way. So for running your jobs in Elastic Map Reduce, there's basically two ways of doing it. One is you can do what we just did, which is create the cluster here. So like I showed you, right? Where's that now? Yeah. Right. So calling MrJob create cluster, providing your conf file, that ultimately, notice, returns basically an ID for the cluster itself. So once you have your cluster running, then I can basically run the various jobs in pretty much the same way that I ran it from the command line. So it kind of looks like this. So. Right, there's a couple of extra parameters here, right? So one is the tac r EMR basically specifies that's the runner we're using. Now run it in basically in the cloud. If you specify the cluster ID, right? So then I can come back over to here. And paste in that cluster ID. I could look it up there, or I can actually just come here and grab this. Either way. Right, so that's how I would specify that. Now, a couple of other things. If you want to have your input files in an S3 bucket, right? So I could run it this way, and basically it will upload my input file to EMR, and basically then run it and give me the result. Alternatively, I could pre-upload it to an S3 bucket, which I believe I have. So if I come to here, I have a little bucket here I've created. I have a files section, and notice there's words alpha dot text. So if I wanted to specify, no, I don't want that. If I wanted to specify to use that file, I could just do this right here. Now, if you didn't start up your own cluster previously, and you just want to do a kind of one-off job, and I don't recommend that because, again, the time to start up the cluster typically is around 10 minutes, so you're going to wait a long time for that to do it. But if you did want to do that, all you need to do is take out the tac cluster ID option, right? So if we take out that, basically what it says is, oh, start up a brand new cluster based on the conf file that we've given you, and run this particular job. Let me go ahead, let's see if I can actually submit this job while this is, because by now this is probably getting close to being, to running. Really? Now, why are you doing that? It's probably actually an error with something else, but let me just see. Suppose I don't specify that.
The folder that it is creating for S3, MrJob 7 and 4D CA.
Right, so that's the folder that it created on its own for storing the temp stuff and all of that.
So what will happen to that folder? Will that folder remain as it is? Or
That folder will remain. I mean, once you're done, you can actually delete it, right? So if I come over here, right, there's the little folder that that's actually using. Let's see what this is, where this is right now. Bootstrapping, okay. So we'll see if we can have to. So again, some notes on this. Startup time for the cluster is significant. Also, the runtime, in fact, you'll notice when it actually runs on the cluster, I think it takes longer to run on the cluster than it does on my local machine. Now, why is the reason for that? Anybody? So, here's basically the issue. The splitting the data up and farming it out across multiple machines, moving various parts of the data across the network and all of that to reassemble it, that's basically going to add additional overhead that I don't have when I'm running on my local machine because everything's running locally. Okay. Now you might say, well, wait a minute, but isn't this designed to deal with large amounts of data? Absolutely, but that's kind of the point. See, the point is, once I get to data sizes that would actually kill my personal machine, right, that's probably where I'm going to farm that out to the cluster, because at that point we kind of reach that sort of break-even area where, yeah, we really actually need that because we don't really have the resources to run that efficiently locally. Okay, but nevertheless. Oh yeah, so is it running? Yeah, it is running. Cool. Right, so yeah, you can see it's definitely taking longer to run than it did on the local machine. Yeah.
You said that we have like central node and two core nodes.
Yep.
So we can connect to this central node and those two core nodes is like in private network.
Yes, you can. Right. So notice. So if I come here, if I click on the cluster itself, right? So we get a bunch of stuff. So if I go to hardware, you can see here's the information about the stuff. So notice we have a master. In this case, actually, it looks like I only have one master, one of each. That's weird. But there's my master, and so notice I get an EC2 instance ID. I can actually open that up in the console to get the public DNS number and so forth. Now, if you did want to SSH into it, and incidentally, they actually install and have running a program called HUE, HUE, which basically is a web interface for kind of managing Hadoop jobs and things like that. It doesn't necessarily play terribly well with the streaming API, which is why I didn't bother showing it, but you could actually use it. If you do want to SSH into the instance, however, SSH is turned off by default in the security group. Okay, so if you do plan on SSHing in, you're going to need to come over to here and do the usual of come down to the security group, right? Basically, go to your inbound rules and essentially add a rule for SSH, right? So I could have there we are, SSH, and we could set it to this here. And now it would be able to SSH into the machine. Yeah.
You mentioned HUE, yes. So is it like management for the Hadoop for splitting the time for different jobs, no?
Right. So the Hue software, and I haven't played with it a ton. I kind of opened it up to take a look to see what features there were there and all of that. It does seem to have the ability to, for instance, upload jobs, upload traditional Hadoop jobs. So there's things like upload a jar file and stuff like that for doing that. I think there's also some monitoring in there and stuff like that, but I didn't really play with it very long. Let's see if this actually finished.
So if I delete my cluster, so it will delete all the instances, or do I have to delete?
Right, so when you terminate the cluster, it basically shuts down the instances as well. Right, so once it gets done, it kind of goes through this thing of trying to wait for the log files, etc. You can just hit Control-C to kind of skip through that. Yeah, right, there we go. Okay, waiting for step 2 of 2, okay.
Is there a kind of way of managing how much a job can use of CPUs on the nodes or RAMs? Like if several users try to use the same Hadoop cluster, is there a way?
I'm not aware of that level of control. I don't know that you can sort of configure it at that. I mean, if that really were, if it's an issue, then I mean the one solution is just spin it. You have separate Hadoop clusters for your different users, right? So it's okay. You have one configured for you. You have another one configured, right, and so on.
So in the instance you specified 2. So
Yep.
what was that?
Right, so that's the number. That probably is why I have total of 2 instances. Although I thought that was actually just the core, but apparently it seems to be. Right, so we could bump this up. I mean, if you wanted, bump it up to 5 and whatnot.
So like if I bump it up to 5, so there will be one master.
Then you're gonna what you always have one master, and then you basically have multiple other. Then you have your other instances that are doing the most of the work.
So what if I specify only one? Would there be only master?
Then most likely you're only going to get a master, and all the work will be done on the master. But yeah, yeah.
Question, I thought that map reduce can be used on the video adapters. So Amazon doesn't provide such function, or
Oh yeah. So right. So you're talking about GPU computing. Amazon actually does have GPU compute units that you can use. So I forget what the names are, but if you sort of go through the instance types, you'll actually be able to find ones that are those sort of compute intensive types of systems, and then you could make use of that.
yeah, but it's kind of it's not so easy like it done on Python. You need
Chances are, yeah. I mean, look, if you really want speed, you don't want Python. And for a number of reasons. I mean, it's not that I'm knocking Python. I mean, Python is known to sort of have some speed issues and things like that. So, you know, if you're really trying to crank out speed, that, you know, something like MrJob is good for sort of proof of concept types of things and being able to kind of rapidly prototype and stuff like that. But if you really are getting into performance issues, then you're probably going to end up writing it in something like Java or another language that's going to be a little bit faster for you. Okay.
So it would be nice to see like heterogeneous like network, and you can launch not just on the instance but on the video adapters, like
Right.
the mappers and reduce.
Yep. All right. No. So I don't know if let's see. Did this give it to me? Okay, so I should. Well, maybe not. Let's see. Why do I have the ones in there? That's weird. May not have saved it. All right. But there's our results. Okay. So it gives you kind of an idea. As I said, what's nice about MrJob, it's really easy to run it locally and things like that. If you're not dealing with giant data sets, then certainly you can do that. You know, running it at least once on EMR is definitely worth it. All right, so next class, basically, I will unveil the final exam. So it's not an in-class exam, so don't panic about that. It's a take-home exam, and yeah, we'll see you next time.